Section 9.5 is on dilations and scale factors. The first definition that you need to know is what is a dilation. It is a transformation, like we've talked about reflections and rotations and translations in the past, but it is not an isometry. Remember that an isometry is when the pre-image and the image stay congruent. These are dilations, which means the pre-image and the image will not stay congruent. The image will be either greater than or smaller than the original figure. We talk about scale factors because that's the multiplier that we use to make a figure either bigger or smaller from its pre-image. We will be multiplying and dividing. We will not be adding or subtracting with scale factors. If I give you the pre-image and the image and ask you to find the scale factor, then we would do that by taking the length of the image and dividing it by the length of the pre-image. We have two kinds of dilations. One's where the image is larger than the pre-image. That's called an enlargement. And then the scale factor between those two would be greater than 1. The dilation is called a reduction if the pre-image is bigger than the image, if the second image is smaller than the original. And in that case, the scale factor would be a fraction of some kind, 1/2, 1/3, something to that effect. So your first example is to describe the dilation that they give you. So it says if the green triangle, that's this one, is the pre-image and the orange triangle is the image, so it started at the green and went to the orange. First of all, what kind of scale factor is it? If it started as the green and went to the orange, you'd have to decide if it's an enlargement or a reduction. And the answer is it's a reduction. The orange one is smaller than the original green triangle. The scale factor, in order to find the scale factor, the definition says take the length of the image divided by the length of the pre-image. So you find two values in the triangles that are corresponding to one another. So a value in the orange triangle that we know is this right-hand side, and we know that the value is 2. Now, its corresponding piece in the green triangle would not be 1, which is a common mistake that a lot of students make. You have to think about what would the side length be of the entire green triangle on that side. And so in that case, you'd have to add 2 and 1 together, and the green triangle's side would be 3. So it is a reduction with a scale factor of 2/3. If the orange triangle had been the pre-image and the green triangle had been the image, in other words, the orange is the one you started with and the green is the one that you got to, in that case, what would the scale factor be? Well, first of all, it's getting bigger. If you're starting at the orange and going to the green, then you know it's an enlargement. And in that case, you would take, the image would be the green, so you would take the 3 divided by the 2. So it would be an enlargement of 3/2. Another type of example that you are going to see is one where you start with the pre-image and then you actually use the scale factor to multiply and then create a new image. In this case, we're going to dilate a segment with endpoints that are at 2, 2 and at 0, 1. And we are going to use a scale factor of 3. So our first coordinate is at 2, 2. Our second coordinate is at 0, 1. This is our pre-image. Now to change our pre-image, we're using a scale factor of 3. That means we're going to multiply all of our values times 3. So we're going to take each of our coordinates times 3. 2 times 3 is 6. 2 times 3 is 6. 0 times 3 is 0, 1 times 3 is 3. That gives us our 2 new sets of coordinates. I can now plot those points, 0, 3 and 6, 6. And you can see that this segment is 3 times longer than our original. The blue is the pre-image, the red is our image. If we wrote that in rule notation, it would look something like this. X and Y would move to, X would move to 3X and Y would move to 3Y. Those are the types of problems that you're going to see today. Ones in which you're going to use the scale factor and multiply it to get the image, and those in which they give you the pre-image and the image and you have to find the scale factor. If I would have given you the image and asked you to go backwards to find the pre-image, you would have had to divide by 3 instead of times by 3. So keep that in mind. There may be some of those problems. Your homework for this section is as follows.